right here as I'm doing everything. I guess it's not very smart to know when I'm doing something when I'm not doing something. Hey, let's start right in the middle. All right. 12.4, solving multiplication and division equations. Okay, very simplistic. I want to look at a couple of different things. Obviously, that would be an equation with multiplication. Okay, this is an equation with division. Okay, remember that this equation is the same thing as this equation here. Okay, those two are equivalent. All right, one's listed vertically, n over 6 equal 9. Other one horizontally, n divided by 6 equal 9. Okay, so understand that that's what we're doing on both of them. All right, now we are still talking about using the inverse operations to solve equations. Okay, the inverse operation of multiplication is, what do you think? Division. There we go. At least one of you is not having brain zombie today after another holiday. Never understood that. We come back from a 2-week holiday, and then a week later we get a 3-day weekend. Then the next month we get another 3-day weekend. Next month we get a week off. Next month we get 4-day weekend. Next month we get... So it's just like holiday, holiday, holiday. All right, so then the inverse of division then would be what? Multiplication. Okay, so to solve an equation that has multiplication in it, we have to divide by something. Okay, to solve an equation that has division in it, we have to multiply by something. Once again, to solve is to get the variable isolated by itself. Okay, so in each one of these problems that I listed, 5n equals 75 and n over 6 equal 9, the objective is to get that n by itself. Okay, on one side or the other of the equation. Okay, understand that you could have 75 equal 5n and it's the same thing. Or we could have over here 9 equal n over 6, and that would be the same thing. Okay, so just because they change sides with the numbers or the variables doesn't change anything. We still solve them the same way. Okay, so if we look at 5n equals 75, we have said that that's multiplication. In other words, they want to know 5 times some number equals 75. Okay, we don't know what that number is. Okay, that's what we have to solve for. So we have to solve for what is that n? What can I multiply by 5 to get 75? Okay, the way we're going to do that is this way. We're going to take and divide both sides by 5. The reason I'm dividing both sides by 5 is because I'm multiplying 5 times n. So the inverse of multiplying 5 times n would be to divide 5 by both sides. Once again, we have to do it to both sides or we no longer have an equivalent equation. Okay? So we have 5n, and 5 goes into 5 how many times? One time, right? So these two cancel out, leaving me with 1n, which is what I'm looking for. I don't have to put the 1. I'm just showing you that it's not 0, okay? Because if it was 0 times n, then we'd have an issue. Because it'd have to be 0. That's equal to, so over here, all we're doing is dividing 5 into 75. Well, 5 goes into 7 one time, be 5, remainder 2, Bring down my 5. 5 into 25, 5 times. Be 25. That would be a 0. And so my answer is n is equal to 15. So if I was to check that problem, I'd simply do this. I'd plug in my answer, 5 times 15 equals 75. Now this is how we check it. Okay, well 5 times 15 is 75. 75 equals 75. So that is a check mark. That does check. That is the solution to this equation. Okay? Now, let's look at the other example I gave you. Let's see, n over 6, right? N over 6 equal 9? Is that what I put? Okay. N over 6 equal 9. Okay. Now, this one seems maybe a little bit more difficult, but it's really not. Okay? We're simply doing this. We're dividing 6. In other words, what we're saying is this. 6 into some number n is equal to 9. So what I have to figure out is what goes into the bracket. Okay, that's what we're looking for. We're looking for, in this case, the dividend. Okay? And how you would satisfy that is you would simply take 6 times 9. And that would give you what goes underneath the bracket. Okay? Here's how we show it. So really this is just 6 times 9 would equal your n. Okay? Here's how we show it in our problem. N over 6 equal 9. Alright? Well, I've got to get rid of that 6, so I'm going to multiply both sides by 6. On this left side, I can cross cancel. That gives me a 1 there and a 1 there, and so that gives me n equals 9 times 6 is what? 54. And that is your answer. Okay? So we use the inverse operation. We use multiplication, multiplying both sides by 6 to solve the equation, because we were dividing by 6 in the equation. Once again, the whole ordeal is to get n isolated. Okay, we want to isolate the n. And we obviously did that with the n equal 54. Okay? Alright, let's look at another one. Oh, let's see here. $87 equal 3n. 87 equal 3n. Now, this is another one of those problems that, oh, it's reversed. Okay, well, this and that equation are exactly their equivalents. Okay, so if you like it better with the variable on the left side, less confusing to you, then go ahead and switch it. Okay, it's just 3n equal 87 is the same thing as 87 equal 3n. All right, so to solve this expression or this equation, what do we have to do? If we're multiplying, how do we solve it? What operation do we use? Jonah? Division. So, how am I going to express this problem? How am I going to do that? Isaac?
3 goes into 87 how many times?
Okay. Now, remember, we've got to do it to both sides, so we're going to divide 3 into 3, and we're going to divide 3 into 87. So 3 goes into 87, 3 goes into 3. 3 goes into 3 one time. 3 goes into 87, well, 3 goes into 87 3 goes into 8. 2 times would be 6. Remainder 2. Bring down my 7. 3 into 27 goes 9 times, would be 27. Remainder 0. So n is equal to 27. Now, once again, you don't have to put 1 in. N and 1 n are exactly the same. Okay. All right, let's look at another division one. N over 4 equal 32. N over 4 equal 32. Jonah. Oh, yes, thank you. I don't know why I put 27. I was thinking of the 27. I was thinking of that 27 right there. All right, so n over 4 equals 32. So what do I do here? It's a division problem. It's a vertical division problem. So what do we do? Not everybody at once. Don't want everybody to wake up at the same time. Noah.
You put in division 4 divided by n equals 32.
Yeah, but how do I solve it? How do I show it? You're on the right track there, but how do I show what I'm going to do? If I'm dividing by 4 to both sides, okay, how do I show what I got to do, Jonah?
On the n over 4,
Uh-huh.
put 4, the dot.
Okay, so we're going to go 4 times on the left side. Okay. Okay, that's how we show it. That's right. Now, those cancel, leaving me with n equal, what is 32 times 4? 128. Now, in your book, or in the paper you've got, it looks like, problem looks like this. N over 4 equal 8. Okay, my brain races ahead and it thought of the answer before I was supposed to give you the answer, and so I put 32 instead of 8. So the answer to this one is what then? What would the answer to n over 4 equal 8 be? 32. Okay? Sometimes I can't stop my brain. It just goes to the speed of flash. What, you don't think it does, Brandon? Careful with that next answer. There you go. That's the right answer. All right. I'm going to give you 2, and I want you to do these 2 on your own. Let's see here. 11n equal 110, and then 10 equal n over 6. n equal 110, and then the other equation to solve is 10 equal n over 6. Okay, I'll give you a couple of minutes to solve those. All right. Let's look at 11n equal 110. How do we solve this? Somebody tell me, how do we solve this? Brandon, glad you volunteered. How do we solve 11n equal 110? Okay, we divide 11 on the left side. Okay, so what do we do on the right side? Yep, divided by 11. So 11 into 11 goes one time, so that just leaves us with n. And then we have 11 into 110. How many times? 10 times. Good. So the answer there is 10. Now, what about on our division one? 10 equal n over 6. 10 equal n over 6. Let's see, who else wants to volunteer this morning? Michael, what do we do? Did you get an answer?
Yes.
What did you get your answer as? 60 is correct. And yes, you did it correct. You take and you multiply by 6 to both sides. Okay? 6 over here on the right side cancel each other out, leaving me with n. And then 6 times 10 is 60. Okay? Now, remember, this problem, the division problem, could have been expressed as such. Like that right there. That had been the same problem. Okay? So if you see it better visually like that, then go ahead and do it that way. Alright? Now, let me show you one. Let's see here. There's it. 18x equals 12. Okay? Now, they want to know, what can I multiply 18 by to get 12? Okay? So what can I multiply 18 by to get 12? What's the very first multiple of 18? 18 times 1, which would be 18. So we're in a problem. So our nice little whole number answers. Okay? So it tells me then that whatever x is, it has to be more than or less than 1. Less than 1, because 18 times 1 is 18. So I got to find 18 times something equal 12. Okay? And that's why the process that I'm teaching you is very important. Okay, let's not even think about the answer for a second. Let's just think about, what have we done in the previous 4 other multiplication problems? What did I do? Jonah? I divided. So here, what do I need to divide by? 18 or 12? 12? So what am I doing? In other words, what operation am I doing to 12? Is there any mathematical operation going on this side? No. So I don't divide by 12. Over here, I'm multiplying. So that's where I have to divide. So I have to divide both sides by 18. 18 over 18 goes 1 time, so that gives me 1x, which is just x. Now here's the part that's different. We have to look at 12 over 18 just like we needed to look at 110 over 11. That's just a fraction. Okay? Is 12 over 18 a proper or improper fraction? Huh? Proper or improper? Who thinks proper? Who thinks improper? Okay, what is the definition of a proper fraction? Isaac?
A fraction that cannot be made into a smaller fraction.
No. It's a good guess, but no. What is the definition of a proper fraction? Don't make me go back into my notes. Jonah? No, that would be one that could be simplified or reduced. Noah? Right, the numerator is smaller than the denominator. Is the numerator smaller than the denominator here? Yes. So that's already a proper fraction. Okay? X is equal to 12 over 18. The only thing I have to do is can that be reduced? Can 12 over 18, does it have a common factor between your numerator and denominator that you can reduce it by? Isaac? Okay. I can divide it by 6. So 6 goes into 12 2 times. 6 goes into 18 3 times. So X is equal to 2/3. So what that says is if I take 18 and multiply it by 2/3, it's going to give me 12. Okay? So it's very important that you understand what you're looking at. Now, we got on a roll with these first few examples because why? They were all improper fractions. And they were all improper fractions that end up being a whole number. Okay? Well, that's not always going to be the case. You're going to have decimal answers sometimes, not tonight, okay? But in the future, you'll have decimal answers, you'll have mixed numbered answers, you'll have whole number answers, you'll have fractional answers. Okay? So understand, it doesn't have to be this nice little neat whole number and we're done. Okay? All right. So what you're going to do for your homework is you're going to do the one that says written exercise. Okay, when we used to use this book a while back, kids would always get confused and start doing the class exercise instead of the written exercise. So you're doing the written exercise, and we're not gonna have a lot. We're gonna do 1 through 22. Okay, of which we did about 6 or 7 of the examples, so we did close to half, not quite, but 1 through 22 is your work. Okay, still got about 8 minutes left in class, so let's go ahead and start it. Make sure you don't lose your sheets. Okay, make sure you don't lose your sheets, because unlike my other textbooks, I don't have this one on my computer, so I would have a hard time getting it sent to you if you left it here or something. All right, so make sure you get it put where you'll take it home. So obviously in 8 minutes you're not going to finish it. Yes, Brother Noah. No, you have to show your work. Remember when Xavier asked me that question last week? And I showed him why we have to do it, because we're fixing to get into 2-step problems on Thursday. Now, tomorrow we won't have class because it's chapel day. Okay? I heard that. That all yes. Oh. Yeah, we're all thinking it's Monday because some of the kids tried to go to Spanish instead of computer because they thought it was Monday and not Tuesday. So this Tuesday, so tomorrow we will have chapel, so realistically, unless something happens, we will not grade this until Thursday, but like I've always said, let's be proactive and get it done, and that way if something was to happen, never know, you will have it ready to grade tomorrow, because that's when it's actually due.